Hello students, today we begin with a new lesson in science. Is matter around us pure? Is matter around us pure? You must have noticed the word pure written on the packs of certain consumables like milk or ghee. For a common person, pure means having no adulteration. But for a scientist, all these things are actually mixtures of different substances and hence not pure. In today's class, we will discuss about what are pure substances, mixtures, solutions, suspensions, and colloidal solutions. We've discussed this in the previous lesson. What is matter? Anything that has mass and volume occupies space is called matter. And matter, as we know, is present in three states: in the solid state, liquid state, or the gaseous state. Now, matter can be further classified into pure substances and into mixtures. In pure substances, they can be further classified into elements and compounds, and elements are further classified into metals, non-metals, or metalloids, while mixtures can be of two kinds: homogeneous and heterogeneous. Based on its chemical composition, matter is classified as pure substances or mixtures. Now, pure substances have a fixed composition, whereas mixtures have no fixed composition. We will talk about this a little more in detail. So, pure substance is a substance that consists of only a single type of a constituent particle. Like, for example, a bar of gold. It is made entirely of gold. Hence, this is a bar of pure gold. Now, pure substance can be classified into elements or compounds. An element is a basic form of matter that cannot be broken down into simpler substances by chemical reactions. Like, take the example of oxygen. Oxygen is an element and it cannot be broken down into something more simple than what it is. It is present in the basic form, that is oxygen itself. Now, compounds. A compound is a substance composed of two or more elements which can be chemically combined with one another in a fixed proportion. Like, if you take a water molecule, we know to form a water molecule we have two atoms of hydrogen and one atom of oxygen. These two will combine together to form one molecule of water. This is the compound which is formed when hydrogen and oxygen combine together. So, a compound is a substance which is composed of two or more elements chemically combined with one another in a fixed proportion. So, this is a summary of what I've just said, that pure substances can be classified into elements and compounds. So, let's look at elements. Elements can be further classified into metals, non-metals, and metalloids, and we'll take a look at this. Elements, as we have just discussed, is a basic form of matter that cannot be broken down into simpler substances by chemical reactions. An element is a pure substance, and till now 118 elements have been discovered. On the basis of variations in properties, elements can be broadly classified as metals, non-metals, and metalloids. Now, what are metals? A metal is an element that is malleable, ductile, sonorous, and conducts heat and electricity. Malleability means that this metal can be hammered into thin sheets. Ductile means it can be drawn into wires. Sonorous means making a ringing sound when hit, and they can conduct heat and electricity. Examples are gold, mercury, gallium. Non-metals are elements that are neither malleable nor ductile and do not conduct heat and electricity. Examples would be hydrogen, oxygen, and carbon, among a few. Metalloids are elements that have intermediate properties between those of metals and non-metals. Examples would be boron, silicon, germanium, amongst a few. Mixtures are constituted by more than one kind of pure form known as a substance. Now, most of the matter around us exists as mixtures of two or more pure substances. For example, seawater, soil, these are all mixtures. Now, depending upon the nature of the components that form a mixture, we have two types of mixtures: homogeneous mixture and heterogeneous mixture. A homogeneous mixture is a mixture in which the constituents are uniformly distributed throughout, that is, without any clear boundary of separation. Now, air is a homogeneous mixture of gases, and its two major constituents are oxygen and nitrogen, and there are other gases in small quantities. Heterogeneous mixture is a mixture that does not have uniform composition, that is, it will have visible boundaries of separation between its constituents. Here the constituents of the mixture can be seen by the naked eye, and examples of homogeneous mixture would be sugar and sand mixture, salt and sand mixture, or polluted air. Let us look at a few differences between compounds and mixtures. In compounds, the elements are present in a definite ratio. This is because they will chemically combine to form the compound, so they are always present in a definite ratio, whereas in mixtures, the substances will mix in any ratio. In compounds, the constituents cannot be separated by simple physical methods, whereas in mixtures, the constituents can be separated by simple physical methods. In compounds, the compound is always homogeneous in nature, whereas mixtures can be homogeneous or heterogeneous in nature. What is a solution? A homogeneous mixture of two or more substances is called a solution. A solution is sometimes also called a true solution. Examples would be lemonade, soda water, salt solution. So these are all examples of solutions. Now in a solution, there is homogeneity at the particle level, which means the particles of dissolved substances are evenly distributed in the solution and cannot be distinguished from one another. There are two main components of a solution: solvent and solute. The solvent is the dissolving phase, and the component of the solution that dissolves the other component in it is called the solvent. Whereas the solute, which is the dissolved phase, would be the component which is usually present in lesser quantities, and the component of the solution that is dissolved in the solvent would be called a solute. Some examples of solutions would be a sugar solution, in which sugar is the solute and water is the solvent. A few more examples of solutions would include tincture of iodine, wherein alcohol is the solvent and iodine is the solute, and aerated drinks, in which the water would be the solvent and carbon dioxide would be the solute. Let us discuss a few properties of a solution. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nanometer in diameter. The path of light is not visible in a solution as the particles do not scatter a beam of light passing through the solution. A solution is stable. That is, the solute particles do not settle down when left undisturbed, and the solute particles cannot be separated from the mixture by the process of filtration. Now that we know what solution is, let us discuss about suspensions. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Examples would include a mixture of chalk powder in water, a mixture of sand in water, or smoke coming out of a chimney of a factory. Properties of suspensions. Suspension is a heterogeneous mixture and its particles can be seen by the naked eye. Particles in a suspension can scatter a beam of light passing through it and can make its path visible. This is known as the Tyndall effect. If you remember what we said about solutions, the solutions would not scatter the beam of light when it passes through it. Now, why is this so? This is because the particles present in solution are very small and hence they will not be able to scatter a beam of light passing through it, and the path of light is not visible in a solution. But in a suspension, the particles do not dissolve but they remain suspended throughout the bulk of the medium, and hence they will be able to scatter a beam of light which passes through it. A suspension is unstable. The solute particles settle down when suspension is left undisturbed, and they can be separated by the process of filtration. When the particles settle down, the suspension breaks and it will not scatter light anymore. For the suspension to scatter light, the particles need to be suspended in the medium and not settle down. Colloidal solutions. A colloid or colloidal solution is a mixture that is actually heterogeneous but appears to be homogeneous as the particles are uniformly spread throughout the solution. Examples would include milk, shaving cream, cheese. Colloidal solutions are also called colloidal sols. A few properties of a colloid. A colloid is a heterogeneous mixture. The size of the particles of a colloid is too small to be individually seen by the naked eye. Colloids are big enough to scatter a beam of light passing through it and will make its path visible. Colloids are quite stable. The particles do not settle down when the colloid is left undisturbed. And particles of a colloid can pass through filter paper. Therefore, a colloid cannot be separated by filtration. However, they can be separated by a special technique which is called centrifugation, which we will be discussing later. Let us quickly summarize what we have discussed till now. Matter, as we know, which may be present in solid, liquid or as gas, can be further divided into pure substances or mixtures. Now, pure substances have fixed composition, whereas mixtures have no fixed composition. Pure substances are further divided into elements, compounds. Now, elements cannot be broken down into simpler substances. Examples would include copper, oxygen, and compounds can be broken down into elements by chemical or electrochemical reactions. For example, water, methane, They can be broken down into elements. Now elements are further classified into metals, non-metals or metalloids. Let's go to mixtures. Mixtures are of two kinds, homogeneous and heterogeneous. Homogeneous mixtures are those mixtures which have uniform composition, example sugar in water, and heterogeneous mixtures are those mixtures which have non-uniform composition. Most of the natural substances are not chemically pure, and hence different methods of separation are used to get individual components from a mixture. Sometimes special techniques are adopted for the separation of components of a mixture. We will do a brief of all the methods which can be used to separate the components of a mixture. Evaporation. It includes the separation of volatile components from non-volatile components. Centrifugation would involve the separation of colloidal particles from solutions. A separating funnel can be used to separate a mixture of two immiscible liquids. Sublimation will be used to separate a solid volatile component from a mixture. Chromatography can be used to separate components with the help of some solvent. Examples of a few more methods would include distillation, which is used in the separation of two miscible liquids. Fractional distillation, which is used in the separation of colloidal particles from solutions. We can also separate the different gases present in air. Crystallization is used in the separation of pure substances from its impure form. And we can also separate the components of a mixture by the process of purification. This is just a gist of the different methods that can be used to separate the components of a mixture. We will do this in detail in the next video. To revise the concepts that we have discussed in today's class, don't forget to like, subscribe and share, and I'll see you soon with the next video.